Hello, everybody. Welcome to International Nurses Day 2026. And this is the part two video where I will go through an example to show you how to do the work. There will be 12 prizes randomly drawn from correct submissions, $40 each, 4 for pleasant surprises, and 1 grand prize surprise. And I have them on here. There are 12 of these, and if you look over here, it says count 12, and then you have 4 surprises and 1 grand prize surprise. That's 5. The date is also Florence Nightingale's birthday. So this is Bible Action Math, and we usually have a Bible verse, 1 Timothy 5:23, no longer drink only water, but take a little wine for the sake of your stomach and your frequent ailments. Now, back in the original language, Asthenaeus, this letter right here is a lowercase regular sigma. And the funny part is this last one over here is not a regular sigma, but that one is a lowercase final sigma, or a final lowercase sigma. So this is not great because when you're learning statistics, at least in the United States, you usually have to differentiate sigma and S. This S is not the same as that final sigma, totally different. So this sigma right here represents population standard deviation. This one represents sample standard deviation, population, and a sample. Okay. So in the context of this verse, Timothy, all of the ailments he ever had would be the population. And the key word that happens a lot is all. It's just a key word. It's used a lot though. And then sample, if you want, you could say the keyword is like some. So all of his frequent ailments is the population. If you get a sample of some of them, that's called a sample. And the sample could be either which ailments he had, or it could be what days they were, or something else. So in my huge example today, we're going to talk about blood pressure. My name is Uncle Benny. I'm not a nurse. I'm a math educator. We're going to be using this. This says sys, dia, and pul. So this is systolic blood pressure, diastolic, and pulse. For people who are in the activity, you don't have to use blood pressure monitor, but you do need to have 5 pieces of real data. They do not have to be health related, although it would make sense for them to be. I'm not trying to take your data. I don't want your data, but I do want it to be real. It doesn't even have to be about health. So there's systolic, and BP is short for blood pressure. There's diastolic, and then there's pulse. So pulse is not really blood pressure. These two are, and the machine I'm going to be using measures it in millimeters of mercury, and the pulse, it says per minute, beats per minute, right? So what does systolic, diastolic mean? I'm putting pulse in brackets because that's not really blood pressure. So to find out what they mean, if I'm being real serious, I want to go to Google Scholar probably or something like that. And over here on the right side, if there are links, that means I can probably see the information. So it says older Americans. And once I get here, I don't want to read everything necessarily. But I can press Control F, systolic, and So here they talk about systolic hypertension. And so sometimes when you're reading these articles, you learn something that you didn't know about. Like I didn't know that they specify hypertension by the type of blood pressure necessarily. So I'm not seeing any basic definition right now. So we'll go back to a different article, maybe this one. So it looks like they just think we know it already. So I'm just going to go over here. Maybe the American Heart Association. All right, so systolic blood pressure is the first top upper number. It measures the pressure your blood is pushing against your artery walls when the heart beats. Diastolic is the other number. It measures the pressure your blood is pushing against your artery walls while the heart muscle rests between beats. My blood pressure might be elevated right now because I'm making a video and whatever other excuses I might have. But to take this, I just put my arm in a cuff and press this button. And keep my feet flat on the ground. Systolic is 123. The diastolic is 75 and 73 beats per minute. Okay. So this is not a real fraction, I don't think. It's just the way that we record it. So even though we have three numbers, I'm only counting this as one little data part. And that happened at about 10:29 a.m. on May 3rd. So I'll do that 4 more times. And then I'm going to follow the directions for the International Nurses Day activity. So let's go look at that. We need to turn it into the Google form by May 12, 2026 at noon Eastern. You must find the mean, median, mode, range, and sample standard deviation for a real data set with at least 5 points. You must show work for the sample standard deviation in its entirety, and all of this must be by hand on paper, not a tablet or electronic device, not altered by AI. We're going to think about mean, median, mode, range, and sample standard deviation. Mean is just the sum of all the X values divided by the sample size. So this is a capital sigma, which I think we've already done in the college algebra series. X is the data values, N is the sample size. So in beginning statistics, we usually use lowercase n for sample size, and all of this equals X bar. And this one is a statistic because it describes a sample, SS. Okay. But there's also mu equals the sum of all the X values over capital N. Capital N in beginning statistics is the population size. Capital sigma is still, it means sum, which comes from adding. X is the data values. So if I had all of the blood pressures for the whole population, I could do this, and mu is a population mean. X bar is a sample mean. And some people call this the arithmetic average. Let's take another measurement. There's this cuff right here that I'm putting on my arm. Okay, so that was not good. My systolic, it went up way high. Must have been stressed out or something. So as a basic rule of thumb, for at least me, This number is supposed to be 120 or less, I think. And this one's supposed to be 80 or less. So far, this systolic went up 17 and the diastolic went up 6, but the beats per minute are the same. Now let's talk about median. Median is basically the middle number. For example, if you have these numbers 1, 9, 11, 15, and 3, you don't necessarily have to pick that middle one, but you need to put it in order first. Either increasing or decreasing. 1, 3, 9, 11, and 15. See, increasing. So the middle number is 9. And the median, it sometimes is a big capital M, but not always. Okay. But sometimes there is an even number. 1, 2, 3, 4, 5, 6. So I'm going to put them in order. 1, 4, and I put another 4. So it doesn't have to be strictly increasing. These are the same ones. Technically, that's not increasing. 6, 13, and 18. 1, 2, 3, 4, 5, 6. Now, if these are samples, in sub 1 is 5. That's the size of that sample. And in sub 2 is 6, the size of that sample. Now, this is an even number, so there's no number in the middle, right? So I cross off the last one on both sides, the second to last one, and then I get the mean of these two, which is the sum of the x values divided by that n, which in this case is actually just 2. And that means 4 plus 6 divided by 2, which is 5. So the first median was 1. When you're starting a statistic, the sample size is n, the population size is capital N. But when you move along later, they stop using the little n's. So if I go to Google Scholar and I just look up something that I feel like looking up, like, and then I can search for little n. Not much. Get it to search for sample. See, here they're using capital N for the sample size, probably. The observations are indexed from little I equals 1 to capital N, where capital N is the total number of observations. But in the beginning of statistics, where I come from, we use little n for the sample size. And then later on, it changes. I forgot to put the time right here. And that happens with data. It's messy. Now, these things look like fractions, but they're not really. Okay. So let's get another reading. There we go. Good old Uncle Benny is getting back to where he needs to be a little better. 124 over 80, 72 beats per minute. And now the time was about 10:43 a.m. Now, I also don't want these to look like fractions anymore, so I'm going to put like boxes over these. There we go. I just made that up. I don't know what doctors do. Just try to make it not look like a fraction right now. Okay. Now, for those of you who are going to participate in the giveaway, we need to have a process pick with at least part of our hand and all of our writing utensils. So last time I didn't enforce the writing utensils. This time I did. But what else do I need? My pencil. Okay. So this is my process pick, something like that. Okay. And then at the end, we'll have a final pick too. All right. So mean and median. Next, we need mode. So these things are so far are called measures of center. And the keyword is most. So what happens the most? So in this one, on the top, set one, most people would say no mode. A few people would say every one of those numbers is the mode because they all happen the most number of times, which is once. For the set two, it just has one mode and it's 4. So it's unimodal. And if these were both 13s, it would have had 2 modes and it would have been bimodal. And then we have range. The range is a measure of disbursement and it's easy. You just do max of all the data values minus the minimum of all the data values. Now, when you're showing work, you don't even have to do that. I know you can do it in your head. Okay. So the range of set one, you don't have to show the easy work for that. It's 15 minus 1 is 14. And the range of set 2 is 18 minus 1 is 17. And that takes us to the hardest part, which is the sample standard deviation. So remember I was talking about the difference between a population and a sample. Specifically, we want a sample standard deviation right now, not a population one. And the formula is different. This is the formula I would be using if I was doing a population standard deviation. But I'm actually going to use the sample standard deviation. So lowercase s equals the square root of the sum of parentheses x minus x bar squared over n minus 1. And I could talk about it a lot, but this time we'll just do it. So I only have 3 little sets of data so far. So I'm going to need 2 more before I do my real thing. So I'll just do it about set 1 over there. Okay. So this check mark thing means square root. And this is a secret too right here. Okay. Remember capital sigma means sum. That little 2 means squared. That's a normal minus sign. And x bar is mean. So I need to get x bar sub 1. And I can take them in the original order or in the increasing order or whatever. Now, when I'm doing x bar, I divide by n. When I'm doing the sample standard deviation, I have divided by n minus 1, which is based on something called the Bessel correction. So 4 plus 9 is 13, plus 11 is 24, plus 15 is 39 over 5. Back in the directions, first of all, it says you must create a visualization of the data by hand. Ideas include a bar chart, Pareto chart, scatter plot, more. And that depends on your type of data. And then also you have to be at least 18 to get a prize or to be eligible for one. You must have a progress pick, including every one of the writing instruments used in the work, as well as at least part of your actual hand. And I don't show your hand in the video, though, if you win or something. Earth Day, the writing instruments part was optional. A lot of you guys did it anyway, though, because I put it in the rubric. I just didn't explain it in the video that much. But now I do, because we're building. Final pick, family friendly. Round your answers to one more decimal place than the original data had. But that says answers. I don't want to round yet. Okay. 39 divided by 5 is 7.8, not rounded. And I put a nice equal sign because it's exactly. Otherwise, maybe I would have put wiggles. Okay. So let's make the square root a little bigger like that. Down here, I'm going to divide by 5 minus 1, which is 4. So I'm going to do 1 minus 7.8 squared plus 3 minus 7.8 squared plus 9 minus 7.8 squared plus 11 minus 7.8 squared plus 15 minus 7.8 squared. That's work. Now, I didn't want to round this 7.8. I don't want to round it if I can help it right now because I'm not at the end of the problem. But it didn't matter at this point. So I put the wiggles because I'm going to round my answer to the tenths place, which is 1 decimal place. I already have work, so I'm going to finish this on Desmos. Just the scientific part. So square root, and then / 5 minus 1 down there. 1 minus 7.8 squared plus 3 minus 7.8 squared plus 9 minus 7.8 squared plus 11 minus 7.8 squared plus 15 minus 7.8. 5.8. Now, there were a lot of ways to mess that up already. See, it says wiggles. See the wiggles? And I don't even know what the data is, but the units for the sample standard deviation are the same as the units for this. All right, so let's go check it. So we have 1, 3, 9, 11, and 15. So if I say equals average, it already knew A1 through A5, but I could have clicked that and then close parentheses, enter. So they got 7.8. Okay. Now, when I click this spot, I can go to format number and I can get more decimal places. And so it doesn't look like it was rounded. But that's not even what I want. I want equals stdev dot s tab, all of that. Okay. So they got the same 5.8 8 I got. So we probably didn't mess up. Okay. So now I'm gonna check my blood pressure again. Remember, your activity doesn't have to be about blood pressure. It could be something else. And it doesn't even have to be about health if you don't want it to be. So I thought it was going to be a little better that time because I was happy, but it wasn't. So I got a little boost because I got my standard deviation right. And even being an old math guy like me, I still feel good when I get things right. Now it's about 10:58. So I just need one more of these, and then I can get this all of the information I need and have a little fun. So we'll get that soon. But remember the directions said I also have to visualize the data. So I have some data already to show. And you can look around online to give you an idea of what to do. Just don't have the internet do it for you. You can't do that. So first I'll start out with a little sketch. All right. So let's say I want systolic. My highest is 140. I've got about 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can make them be in 20s. That's 160 right there. Now, what do I put over here? That's kind of a problem because I can't really use time because of that. But I could just do instance or something. 1, 2, 3, 4, 5. It's not time. And then this is in millimeters of mercury. And I could put more words here, but this is just a sketch. So my first systolic was 123, about there. My second one was 140. My third one was 124. My fourth one was 130. The fifth one we don't know yet, but we could also do diastolic, right? The first one was 75. The second one was 81. The third one was 80. The fourth one was 77. Okay. And pulse, I'm not even going to do. It's pretty much always the same almost. Okay. So we're having fun today, actually. All right, let's get one more of these. Okay, a little better that time. 123 over 80. And then my pulse went back up to 73. Okay. So now let's see what time it is. It's about 11:03. And then 123, 20, 40, 60, 80, 100, 23 over 80. There's a one way to visualize the data. Again, this is just a sketch. It's definitely not going to win an award. It's ugly. See how ugly that is right there? Really bad. But I was just trying to make a sketch. And you can make yours a sketch or you can make it real pretty. The pretty ones are more likely to win the surprise part. So the thing about it is you can't see the variability that much, right? because I started this at 0. So there's a lot of analyzing we could do here, right? So let's get the actual answers now. So my systolic blood pressure was 123, 140, 124, 130, and 123. For all we know, my machine might be broken. Okay. We don't know. But this is the data. It's real data. Okay. So the mean is those numbers divided by how many there are. 123 plus 140 plus 124 plus 130 plus 123 divided by 5. I'm going to round it to one more decimal place than the original data had. So it'll be the tenths. Now I'll go ahead and use Desmos. It's easier. Divide by 5. 123 plus 140 plus 124 plus 130. Okay, so I don't have to round it. I got exactly 128 millimeters of mercury. Not approximate. I got exact. Okay. The median, gonna line these up. I could do descending order, so if I feel like it. So I'll do descending 140. And there are different styles to do these things. I just had to pick some kind of style. So the median is the middle number because I have an odd number. The median is 124 millimeters of mercury. The mode, remember that's what happens the most. It's 123 millimeters of mercury, unimodal. So over in the picture, two of them are exactly the same. It's the first one and the last one. And that's for the systolic. Mode of the systolic is 123. Okay. Mean, median, mode, range. Is maximum minus minimum. 140 minus 123 is 17. And then the sample standard deviation, little s, is the square root. This is 5 minus 1. And I can go from max to min if I want. Now, I'm going to do a math trick. I'm putting a 2 here because there are two of the same thing, and I know how to do it right. 140 minus 128 is 12. 130 minus 128 is 2. 124 minus 128 is -4. 123 minus 128 is -5. And then 144 plus 4. This is positive 16 because -4 times is positive 16. And this is -5 times -5 is 25 times 2 is 50. And that's 148 158, 164, 214 over 4. So we have 140, 130, 124, 123, 123. But I think that it pretty much explains what needs to be done. You can basically just turn in this page if you want, although this wouldn't win a surprise prize probably because this isn't wonderful and so on. You can have more than 5 pieces of data if you want to, and it has to have at least 5. It had the process pick, it should have the final pick, and a little more explanation would be good, but it does not have to be about blood pressure. If I wanted to keep going, I could compare this to the standard deviation of the diastolic. And what do you think would happen? The variability in the diastolic was less, so the standard deviation would be less there. I could also analyze the rate, but before I let you go, let's brainstorm some other ideas for you guys instead of blood pressure if you don't have a blood pressure machine or something. So you could do is like how many push-ups you can do in a row. So maybe you do 10 and then 13 and then 5 and then 17 and then 21 or something. That's 5 pieces of data. You could do for how long do you run? 6 minutes, 5 minutes, 4 minutes and 28 seconds, 7 minutes and 4 seconds, and 9 minutes. But it doesn't have to be about health because Florence Nightingale not only was a nurse, but she was also a manager and a statistician. So you can make it about how many of your workers showed up on Monday, Tuesday, Wednesday, Thursday, and Friday. 9, 8, 9, 6, and 5. If you're a manager, or you can make it about something like video games. So those are some ideas. I hope you guys have fun with it. And if you have questions, let me know. And everybody have a great day.